Well, first let's recap what alkanes are. They're organic chemicals with the general formula CnH2n plus 2, methane, ethane, propane, butane. They're used as fuels, and so the reaction that I think the IB is talking about is where you get an alkane and combust it in oxygen to make carbon dioxide and water. So that's the reaction I think they're talking about. Alrighty. Kinetically stable. Well, kinetics is an entire unit to do with the rate of reaction. And so for rates of reaction, you have to think about collision theory. So the first part is to do with the frequency of collisions. That's important. More frequent collisions, faster reaction. The second part, you have to consider the collision geometry. And the third part is the energy of the collision. If the energy is greater than or equal to the activation energy, then your reaction is going to occur. Now, not all of these are important. Frequency of collisions is to do with maybe the pressure or the temperature. That's geometry. That's beyond the scope of the IB. It's really this one that we're interested in. So if a reaction is kinetically stable, that means that the activation energy must be really high. So here's the energy diagram. The activation energy must be really big for something to be kinetically stable. So alkanes are unreactive. Methane, gasoline poured on the floor, nothing's going to happen. They're not going to react until you give it a big fat spark or set fire to it. And that gives it energy greater than activation energy, and that gets the reaction to happen. So what about thermodynamics? Thermodynamics, you're going back to delta G is delta H minus T delta S. And so that would give you delta G as negative, which is spontaneous. So which sort of reactions are always spontaneous under any circumstances? Well, it's reactions that are exothermic, and delta S is going to increase. It's going to be positive. So I like to think of exothermic, that's hot, and delta S, the change in disorder, you can say entropy, but disorder also works. If that's increasing, that's also messy. So I like to think the universe likes reactions that are hot and messy. Any reactions that are hot and messy are spontaneous. Well, let's have a look back to this equation, combustion of alkanes. Well, it's definitely hot, isn't it? It's an exothermic reaction. And messy, well, messy tends to mean, in this broad context, that the products have a greater entropy than the reactants, and that almost always means that there's much more gas in the products than in the reactants. And that's definitely true. Whichever alkane you put in, there'll be more gas on this side, the product side. Entropy will be increasing as you make more gas. Okay, so that explains it, and we're done.